Hi, and thank you for your question. So this is question number 14 on the balancing equation worksheet that I posted in the announcements. This one is a tough one. You will probably get stuck on this at some point, and there really isn't a magic pill to figure this out. It really becomes more of a puzzle that you have to work through. So let me show you how far you'll probably get and then where you'll get stuck and what you will need to do to overcome the challenge where you get stuck. So first of all, I'm going to list all of the elements, and you'll see that I do break apart the NO3, and the reason why I break it apart to count is that NO3 does not show up on the other side of the equation. So if NO3 did stay together, I would count it as altogether, but because it does come apart, it decomposes, I can't keep it together over on this side. So that's the first challenge with this problem. Then I have one lead on this side. I'll have 2 nitrogens, and 2 times 3 would be 6 oxygens on the reactant side. And then on the product side, I have 1 lead, I have 1 nitrogen, and I have 2 oxygens plus 2 oxygens is 4, plus 1 oxygen gives me 5 oxygens altogether. I'm going to then, my leads are balanced, so I'm going to go ahead and balance my nitrogen. So I'm going to put a 2 here. This balances that nitrogen. Now I'll have 4 oxygens plus 2 give me 6, plus 1 will give me 7 oxygens altogether. And this is the part that then becomes challenging, because now I need to go and I need to balance my oxygens on both sides. They're the only ones that aren't balanced now. And as you can see, I have 7 over on the product side and only 6 on the reactant side. One of the things that I would do if it was the opposite way is that I would put a coefficient here, probably in decimal form, to try and balance it, but I can't take away any of my oxygens on this side to create the 6. So that means I have to put a number over here to balance the oxygens, and there really isn't a decimal that I can put that that I can then multiply a whole number by in order to balance this out. So when you get one of these impossible situations where there is really no number that you can put on either side, what you can then do, and you won't get 1 this hard on the test, but you can just arbitrarily put a 2 up there. Increase your coefficient by a whole number. So I had 1 there. I'm going to put a 2, and I'll show you what that does. That's just going to give me more oxygens to work with on the reactant side. And by giving me more oxygens to work with, I can then go ahead and manipulate this coefficient to meet my needs, or this one. So what I will get is 2 leads on this side. I'll get 2 nitrogens, and then I'll get 2 times 3 is 6, times 2 is 12 oxygens altogether. So all that I've done here is I have put a 2 in front of this one just to up my oxygen levels, just so that I have more to work with on my product side. In putting a 2 here, I did up my nitrogen to be, this is 4. 2 times nitrogen is 2, times 2 is 4 nitrogen altogether. So that means that I also have to up this one to 4, and also I have to put a 2 in front of here for my lead, so that there, like that. So just by adding the 2 here, I now have to put a 2 here and a 4 here in order to balance out my leads and my nitrogens again. So these are now balanced, And now I go and check out my oxygens. So my oxygens are, I have 2 oxygens here, 8 here. So that's going to give me 10 altogether. 4 times 2 is 8, 9, 10. Whoops. And plus 2 actually gives me 12. So 2 oxygens plus 8 oxygens are 10, plus 2 is 12. So I actually don't have to put anything in front of that coefficient. Very, very challenging problem number 14. Not one you're going to see in a test, but definitely a fun puzzle to solve in chemistry. Thanks for watching. Bye for now.